we're going to talk about finding the least common multiple. This is something that's very useful whenever you need to add or subtract fractions and you need to get yourself a common denominator, preferably the least common denominator. And we do so by finding the least common multiple. The way that we go about doing that is by taking the set of expressions that you're given and factoring them completely. Once we factor them, we need to make sure that every factor that shows up in any of the expressions is represented in our least common multiple, but we can get rid of any duplicates. So what that means is that if we have things down to our factors and we put them having exponents such as 2 to the third or b to the fifth, we can simply look at what is the highest exponent that we have amongst the set of expressions that we just factored. So let's do a couple examples. To find the least common multiple of these three expressions, we're going to start by completely factoring them. We see a 15 out front. We know that 15 is 3 times 5, and 3 and 5 are both primes, so those are going to be two of our factors. A squared, b, c cubed, these are all already factored, so we'll just leave them as they are. Next expression here, we have 16 b to the fifth c squared. The b to the fifth c squared is fine, but the 16 we know is 2 to the fourth. Remember our powers of 2 here. So we can just write that 2 to the fourth, and then b to the fifth c squared. And our third expression, we have a 20 out front. We know that 20 is 5 times 4, and 4 is 2 times 2. So we can write that as 5 times 2 squared. That's our 20, and then the rest of it is already factored, so a cubed c to the 6. Now we need to look at every factor that's represented somewhere in the set of expressions and make sure they're all represented in our least common multiple. So we have a 3 here. It's the only 3 in this set, so we have to make sure we have a 3. We have a 5, another 5. Since they're a duplicate, the highest power, 5 to the first, is all we need to include. So we don't need to include 5 twice. We have, in terms of a, looks like we have an a squared and an a cubed. Cubed being the highest power, so that's going to win out. So we're going to have an a cubed in our least common multiple. Our b's, we have b here, ooh, b to the fifth, that's going to definitely take over. To the fifth power is going to be in our least common multiple. And we have our c's. We have a c in every expression here, but the highest power is 6, so these other ones we can just flat out ignore. C to the 6 will be in our least common multiple. And finally we have power 2 to a power, and 2 to the fourth and 2 to the second. 2 to the fourth is going to win out. So when we go ahead and write out our expression for our least common multiple, we say we start with 2. The highest power of those two was 2 to the fourth, so we'll get that there. Then we'll take our 3. 3, the highest power we had was to the first power out here, so we'll just leave it like that. 5, again, highest power was to the first power, so just leave it as is. A cubed, we had 2 sets of a's. The cubed was the higher power than the squared, so put that in there. Look at our b's. We have b to the fifth was our highest power of b. And our c to the 6 was our last one. We had c's in all expressions, but 6 was the highest power. So we'll get that c to the 6 in there. And then to simplify it, you just multiply everything together. Your variables, not much you can do about those, but your constants you can surely multiply together. And that's going to give you, in this case, 240 a cubed b to the fifth c to the 6th. Let's look at one more example over here. These two expressions both are capable of being factored down. In the first one we see that we have an x in everything, so let's factor out that x right away so that we get that out of the way and make it a little simpler. So x, what we're left over with is x squared minus x minus 2. On the other side here, there's nothing we can pull out of everything, but we know that we can unfoil it. We're looking for two numbers that multiply to 4, add up to negative 4. Those two numbers would be negative 2 and negative 2. So negative 2, multiply to positive 4, and add up to negative 4. So that's what we're going to do, right? X minus 2 times x minus 2. Both of these can be taken a little bit farther as far as factoring. On the left side here, inside the parentheses, it looks like we're looking for something that we can unfoil, and two numbers that multiply to negative 2 add up to negative 1. Those numbers would be negative 2 and positive 1. So negative 2 and 1 multiply to negative 2, and they add up to negative 1. So let's write that as x minus 2 times x plus 1. And we always have to remember to keep that x out front that we had from the start. On this side, we have x minus 2. We have it as a factor twice, so we can write that as x minus 2 squared. And that will simplify this side a little bit. Last step, we need to make sure that all of our factors are represented in our least common multiple. So we have an x out here. It looks like that's the only x we have, so it'll be to the first power. We have an x minus 2 factor. We have an x minus 2 factor on the other side, and that's to the second power, so that'll be the highest power. That'll win out and effectively eliminate that. And then an x plus 1. We don't have that on the other side, so we'll just keep that to the first power in our final answer. So our final answer is going to be, for our least common multiple, we have that x that we originally started with. Mark that off here. We have the x minus 2 term, and we said the highest power was to the second power, so we're going to make sure that that's in our answer. And finally, our x plus 1 term, and that's just going to be the first power. And that is how to find the least common multiple.